10 crazy things you never knew about the supercomputer and quantum computing. But before we start, I would like you to hit that red subscribe button so you never miss out on any of our videos. So guys, here in this video we will tell you some crazy things that you never knew about the supercomputers and quantum computing. So let's first talk about the supercomputers. Guys, supercomputers are the bodybuilders of the computer world. They boast tens of thousands of times the computing power of a desktop and cost tens of millions of dollars. They fill enormous rooms, which are chilled to prevent their thousands of microprocessor cores from overheating, and they perform trillions or even thousands of trillions of calculations per second. All of that power means supercomputers are perfect for tackling big scientific problems, from uncovering the origins of the universe to delving into the patterns of protein folding that make life possible. Here are some of the most intriguing questions being tackled by supercomputers today. Recreating the Big Bang. It takes big computers to look at the big question of it all. What is the origin of the universe? Guys, the Big Bang, or initial expansion of all energy and matter in the universe, happened more than 13 billion years ago in trillion degrees Celsius temperatures. But supercomputer simulations make it possible to observe what went on during the universe's birth. Researchers at the Texas Advanced Computing Center (TACC) at the University of Texas in Austin also have used supercomputers to simulate the formation of the first galaxy, while scientists at the NASA's Ames Research Center in Mountain View, California, have simulated the creation of stars from cosmic dust and gas. Supercomputer simulations also make it possible for physics to answer questions about the unseen universe of today. Invisible dark matter makes up to about 25% of the universe, and dark energy makes up more than 70%, but physicists know just little about either. Using powerful supercomputers like IBM's Roadrunner and Los Alamos National Laboratory, researchers can run models that require upward of 1,000 trillion calculations per second, allowing for the most realistic models of these cosmic mysteries yet. Mapping the bloodstream. Think you have a pretty good idea of how your blood flows? Think again. The total length of all veins, arteries, and capillaries in the human body is between 60,000 and 100,000 miles. To map blood flow through the complex system in real time, Brown University professor of applied mathematics George Kardanikas works with multiple laboratories and multiple computer clusters. In a 2009 paper in the journal Philosophical Transactions of the Royal Society, Kardanikas and his team described the flow of blood through the brain of a typical person compared with blood flow in the brain of a person with hydrocephalus, a condition in which cranial fluid builds up inside the skull. The results could be researchers better understand strokes, traumatic brain injury, and other vascular brain diseases. The authors write. Testing nuclear weapons. Guys, since 1992, the United States has banned the testing of nuclear weapons, but that doesn't mean the nuclear arsenal is out of date. The Stockpile Stewardship Program that uses non-nuclear lab tests and, yes, computer simulations to ensure that the country's cache of nuclear weapons are functional and safe. In 2012, IBM plans to unveil a new supercomputer, Sequoia, at Lawrence Livermore National Laboratory in California. According to IBM, Sequoia will be a 20 petaflop machine, meaning it will be capable of performing 20,000 trillion calculations each second. Sequoia's prime directive is that it better simulations of nuclear explosions and to do away with real-world nuke testing for good. Building brains. So how do supercomputers stack up to human brains? Well, they're really good at computation. It would take 120 billion people with 120 billion calculators 50 years to do what Sequoia's supercomputer will be able to do in a day. But when it comes to the brain's ability to process information in parallel by doing many calculations simultaneously, even supercomputers lag behind. Dawn, a supercomputer at Lawrence Livermore National Laboratory, can simulate the brain power of a cat, but 100 to 1,000 times slower than a real cat brain. Nonetheless, supercomputers are useful for modeling the nervous system. In 2006, researchers at the École Polytechnique Fédérale de Loisiana in Switzerland successfully simulated 10,000 neuron chunk of the rat brain called the neurocortical unit. With enough of these units, the scientists on the so-called Blue Brain project hope to eventually build a complete model of the human brain. Understanding earthquakes. Other supercomputer simulations hit closer to home. By modeling the three-dimensional structure of the Earth, researchers can predict how earthquake waves will travel both locally and globally. It's a problem that seemed irretractable 2 decades ago, says Princeton geophysicist Jerry Tromp. But by using supercomputers, scientists can solve very complex equations that mirror real life. So guys, the above were some crazy things about supercomputers. Now let's discuss quantum computing. Before that, the question is, what is quantum computing? So guys, quantum physics has defied logic since the atom was first studied in the early 20th century. It turned out atoms do not follow the traditional rules of physics. Quantum particles can move forward or backward in time, exist in 2 places at once, and even teleport. It's these strange behaviors that quantum computers aim to use as their advantage. Classical computers manipulate ones and zeros to crunch through operations, but quantum computers use quantum bits or qubits. Just like classical computers, quantum computers uses 1 to zeros, but qubits have third state called superposition that allows them to represent a 1 or a 0 at the same time. Instead of analyzing a 1 to a 0 sequentially, superposition allows 2 qubits in a superposition to represent 4 scenarios at the same time. Therefore, the time it takes to crunch a dataset is significantly reduced. Every day we create volumes of data in order to adequately process to all of its extra, meaning that it requires so much more computing power. That's where quantum computers step in to save the day. Computational chemistry. IBM once said the most promising quantum computing application will be in the field of computational chemistry. It is believed that the number of quantum states, even in the tiniest of molecules, is extremely vast, and therefore difficult for conventional computing memory to process. The ability for quantum computers to focus on existence from both 1 and 0 simultaneously can provide immense power to the machine to successfully map the molecules, which, in turn, potentially opens up opportunities for the pharmaceutical research. Some of the critical problems that can be solved via quantum computing are improved with the nitrogen fixation process for creating ammonia-based fertilizer, creating a room temperature superconductor, removing carbon dioxide for a better climate, and creating solid-state batteries. Cybersecurity and cryptography. Guys, the online security space currently has been quite vulnerable due to the increasing number of cyber attacks occurring across the globe on a daily basis. Although companies are establishing a necessary security framework in their organizations, the process becomes daunting and impractical for classical digital computers, and therefore cybersecurity is continuing to be an essential concern around the world. With our increasing dependency on digestion, we are becoming even more vulnerable to these threats. Quantum computing with the help of machine learning can help in developing various techniques to combat these cybersecurity threats. Additionally, quantum computing can help in creating encryption methods, also known as quantum cryptography. Logistics optimization. Improved data analysis and robust modeling will indeed enable a wide range of industries to optimize their logistics and scheduling workflows associated with their supply chain management. The operating models need to continuously calculate and recalculate optimal routes of traffic management, fleet operations, air traffic control, freight and distribution, and that could have severe impacts on the applications. Usually to do these tasks, conventional computing is used. However, some of them could turn into the more complex for an ideal computing solution, whereas a quantum approach may be able to do it. Weather forecasting. Currently, the process of analyzing weather conditions by traditional computers can sometimes take longer than the weather itself does to change, but a quantum computer's ability to crunch vast amounts of data in a short period can indeed lead to enhancing weather system modeling, allowing scientists to predict the changing weather patterns in no time and with excellent accuracy, something which can be essential for the current time when the world is going under a climate change. Drug design and development. Designing and developing a drug is the most challenging problem in quantum computing. Usually drugs are being developed via the trial and error method, which is not only expensive but also a risky and challenging task to complete. Researchers believe quantum computing can be an effective way of understanding the drugs and its reactions on humans, which, in turn, can save a lot of money and time for drug companies. So guys, that's all for today. I hope you liked the video. If you did, make sure to hit that like button and subscribe to the channel so you never miss any amazing video from us.